in this lesson, you're going to learn about the Pythagorean Theorem. You're going to need the worksheet that says Pythagorean Theorem at the top. Let's go ahead and complete these notes so that you can kind of get an idea of how we can use the Pythagorean Theorem to find different sides of a specific type of triangle. The Pythagorean Theorem is used for a specific type of triangle, like I was saying earlier, and that would be right triangles. So it's not going to work for your acute triangles or your obtuse angles. It's strictly for right triangles. Now we do want to label the right triangle that we have here. Notice that it does have that 90-degree angle in the lower left-hand corner. Now connecting that 90-degree angle, you have two sides, and the two sides adjacent to the right angle are called legs. And again, the way to think about that is the 90-degree angle is going to be touching the two legs. And across from the 90-degree angle, so if I were to kind of draw an arrow here, right across from the 90-degree angle, we have what's called an hypotenuse. Okay, and that's spelled H-Y-P-O-T-E-N-U-S-E, hypotenuse. So that's going to be the longest side of your right triangle. So you've got your two legs that are connected by the 90-degree angle, and you've got that hypotenuse that is right across from it. Now the Pythagorean Theorem is going to describe the relationship between the length of the hypotenuse and the lengths of the legs. So I'm going to go ahead and write hypotenuse here, and length of the legs. So it's kind of a comparison, and we're going to be able to use that comparison or relationship between them so that we can find different leg lengths or even the hypotenuse. Now to do that, you do need to know the Pythagorean Theorem formula. Now this is something that will be given to you on an SOL test. You'll see it on your formula sheet and all that good stuff, but it's just kind of a good idea to have it memorized. The Pythagorean Theorem is c squared equals a squared plus b squared. And this is a very common formula, so you've probably seen it before. Sometimes you might even see it as a squared plus b squared equals c squared. It means the same exact thing. Now just so you know the different parts of this particular formula, the c is always going to represent your hypotenuse because that's going to be the longest length of the right triangle. So c will represent the hypotenuse. A will typically represent the smaller leg, and B will represent kind of like the medium leg. But for all intents and purposes, A and B can be interchanged based on the commutative property. Okay, so now we have a couple examples where we're going to have to be able to find what either a leg is or a hypotenuse is in a particular example. So in the first one, it says find the missing measure of the hypotenuse. So this time we are looking for the hypotenuse. Now we are going to use the Pythagorean Theorem formula to do this. So what you always want to do is you always want to go ahead and write the Pythagorean Theorem formula first. So that c squared equals a squared plus b squared. Then all we're going to do is plug in everything. It's just like an equation. So again, c usually represents our hypotenuse. We don't know what c is, so we're going to leave that as c squared. Now for a squared, again, a typically represents the smaller leg. So if I'm looking at 3 and 4, 3 is the smallest one. So we're going to have 3 squared plus b, which in this case would be 4 squared. So now we're just going to kind of condense this a little bit more. So I'm going to keep c squared as is. And then we've got 3 squared. Remember, that's not saying 3 times 2. It is saying 3 times 3. And 3 times 3 is 9. And 4 squared is 16. Now we can condense this even further. We can go ahead and combine 9 plus 16. So I'm going to write c squared equals, and 9 plus 16 is 25. Now, at this point, you might think that the equation is solved, but it's not. Because if we look, c is not completely by itself. It's attached by that squared. Now, I want you to kind of think about what we learned at the very, very beginning of the school year, and we talked about inverse operations. We said addition and subtraction are considered inverse operations. Multiplication and division are considered inverse operations. So what would be the inverse operation of squaring a number? If you kind of think about it, we were talking about squares and square roots and perfect squares and all that good stuff. So the opposite, or the inverse operation of squaring a number, would be to take the square root. So what I'm going to do is I'm going to take the square root of c, and what happens is that cancels out that exponent of 2. And then, of course, when we're dealing with equations, whatever you do to one side, you have to do to the other. So now I'm going to square root that 25. Now again, the square root and the squared will cancel each other out. So I finally get to bring down c. It's completely by itself. And the square root of 25, we lucked out. 25 is a perfect square. So the square root of 25 is going to be 5. So our missing hypotenuse is going to be 5 inches. So just to kind of recap, we basically wrote down what the Pythagorean theorem was. We plugged in the information, and to be quite honest with you, you could kind of go from this spot to this spot because I'm understanding that you guys know how to square numbers, so you don't really need to show me this step in particular. But I would need to see this step, and of course what your answer is going to end up being after you take the square root. So formula, plug and chug, if you will, where you're inserting all of your numbers that you do have, and then solving for our hypotenuse by square rooting on both sides to give you your 5 inches in this particular case. Now the other example is going to be a little bit different. In this case, it says find the missing measure of the leg. So now we don't know what the leg is. We're given one of the legs, and we're given the hypotenuse as well. So same thing like we've been doing before, we're going to go ahead and write our formula, which is c squared equals a squared plus b squared. And now we're going to start filling in any information that we have. So we actually are given c. C is our hypotenuse, so that would be the 13 centimeters. So I'm going to write 13 squared equals a. We're technically given a. That's going to be that 5 centimeters, so 5 squared, plus b, which we don't know, so we'll leave that as b squared. Now, to solve, we're just going to go ahead and kind of condense things. Again, I kind of showed this extra step, until you guys start to get the hang of it. Now, 13 squared is going to give us 169. 5 squared is 25, plus b squared, which we don't know. Now, to solve this equation, we've got to get that b by itself. It's attached by an addition of 25, and then it's also attached by that square. So I'm going to get rid of what's least attached to it, and at this point, it's that 25. So I'm going to go ahead and subtract 25 on both sides. So this is kind of like an extra step since we are finding a leg. These are going to cancel. 169 minus 25 is going to give us, 144. And then I'm going to go ahead and break down that b squared. Now, just like we had before in this particular problem where we had to do the square root, we're going to do the same exact thing here. To get that b by itself, we're going to have to do the square root. And whatever you do to one side, you got to do to the other. Now, the square root and the squared kind of cancel each other out. I'm going to bring that b down, and luckily for us, again, 144 is a perfect square, so the square root of 144 is 12. So to kind of compare the two different examples, the first one, we're finding the hypotenuse. It's not as much work as when we're looking for a leg. The reason being is that because the hypotenuse is already c squared, and that's on the side of its own, it's easy to solve that problem. But whenever we're looking for a leg, it's kind of embedded in the equation on the other side. So we kind of have to solve everything first and then get rid of that extra leg that we have on the other side so that we can get, in this case, b by itself. So again, just treat it like you're solving an equation. You've got your formula. It's like your recipe. And then everything that's in the problem is kind of like your ingredients for that recipe. So make sure you always use what is given there and then just solve for your unknown, just like you would normally do with an equation. Now for the last example, this is going to be different than the first two because you're not asked to really solve anything. You're just trying to figure out whether or not that particular triangle is a right triangle. Now this is not drawn to scale, meaning somebody didn't take a protractor and measure this out precisely. So it kind of looks like a right triangle, but we have to actually use the Pythagorean theorem to actually see if it really is a right triangle. So what we're going to do is we are going to apply that Pythagorean theorem. So I'm going to write my formula, c squared equals a squared plus b squared. And what we're going to do is we're going to take this recipe, if you will, and fill in all the ingredients that we have. So c squared is going to be representing our hypotenuse. And remember, our hypotenuse is going to be the longest side of our triangle. So in this case, it's going to be 12. So I'm going to go ahead and fill that in. So we're going to have 12 squared equals, remember a technically represents the smaller one, so I'm going to put 6 squared plus b in this case, which would technically represent the 9. Now, all I'm going to do is condense things a little bit by finding the square of each number. Notice we're not really solving anything in particular. Now, I know 12 squared is going to give us 144. 6 squared is going to give us 36. And 9 squared is going to give us 81. Now, the last thing that I need to do is kind of combine like terms that are on the right-hand side. So I'm going to do 36 plus 81. That's going to give me 117. Let me bring down my equals and my 144. At this point, we've pretty much had everything simplified as much as we can. And if we look on the left-hand side, it says 144. On the right-hand side, it says 117. So because both of these are not equal, this is not going to be a right triangle. It may look like one, but in actuality, it is not, because our left-hand side of our equation is not equal to the right-hand side of the equation. So in cases like this, we would say not a right triangle. Now, had one side been 144 and the other side had been 144, then yes, that would have created a right triangle. So to kind of recap everything that we've learned, to solve, you just have to use the Pythagorean Theorem. If you're looking for a hypotenuse, then you're solving for c. If you're looking for a leg, then you're solving for either a or you're solving for b. And then whenever you're given all of the measures and you're just trying to figure out whether or not it's a right triangle, we still use Pythagorean Theorem, set everything up, simplify as far as you can, and then if the left-hand side is equal to the right-hand side, then you've got a right triangle. If not, then it is not. It is just simply a regular triangle.